Electricity is one of our most faithful servants. It gives us light. It starts our cars, has unlimited in aviation, circles the globe with entertainment. It cooks and refrigerates our food. These represent few of the innumerable applications of electricity. Electricity at work. But what is electricity, and where does it come from? To answer these questions, let's look in on the world of electrons. The entire universe is composed of matter. A basic concept of the structure of matter is essential for the understanding of electricity, because the very force that holds matter together has an electrical nature. There are many different substances, each a combination of some of the 92 known chemical elements. Just as yeast, flour, salt, sugar, and shortening are the ingredients used in making bread, so are the 92 elements the ingredients of all matter. And if one of these elements is reduced to its purest, final form, its smallest unit would be an atom. No one has ever seen inside an atom. However, we think of it as a system of electrons circulating around a heavy nucleus at almost inconceivable speeds. In order to explain the principles with which we are concerned in this story, let's assume that we can stop the action within the atom. And further, let's acknowledge that this is a symbol representing the atom and not an attempt to show it as it actually is. It is impossible to show the correct relative proportions of an atom on this screen. For example, if an atom could be as large as the United States, one of its electrons would be only about 100 feet across. Therefore, to tell our story, we must resort to a symbol. Then we can think of the atom as being a group of relatively light, small particles arranged around a heavy nucleus. These are particles of electric energy. The lighter ones, the electrons, are negative electric charges. And the heavier one, the nucleus, carries positive charges. Normally, a state of balance is maintained within the atom by a positive charge in the nucleus equal to the total negative charge of the electrons. And when the atom contains its normal number of electrons, it is said to be in electrical balance, to be in a neutral electrical condition. It is possible, however, to disturb this normal balance, whereupon the unbalanced atom assumes an electric charge. Too many electrons will produce a negative charge. Too few will throw the balance onto the positive side. In order to visualize better the effect of this, let's introduce a color code in which the positive charge, or an absence of electrons, is represented with red, and the negative charge, a predominance of electrons, with blue. Then an object that is in electrical balance will be purple, an equal part of each of the positive and negative charges. We have been concerned so far with the electrons within individual atoms. Now let's see what happens when two or more neutral atoms come together. The outside electrons will no longer move exclusively within their original atoms, but will circulate about both atoms at once. And if we bring many such atoms close together, as in a piece of metal, then many electrons detach themselves from their original atoms and move freely throughout the metal. As long as the metal has its normal number of electrons, it is electrically neutral. But like an individual atom, it can lose some of its electrons and become positively charged, or it can pick up more than its normal number of electrons to become negatively charged. The electrons always try to get from a negatively charged body to one that is positively charged in relation to it. And if they are brought together, the electrons will flow from one to the other until both objects are equally charged. The establishment of unbalanced charges in matter is, in all instances, the principle of the generation of electricity.